Welcome to the CyFy panel, Shaping How the Chips Fall, the race to secure U.S. semiconductor leadership. I'm very much looking forward to an intriguing and insightful discussion about the state and challenges of the U.S. semiconductor industry, technology leadership, new U.S. policies and global dependencies and implications thereof. My name is Andreas Kuehn. I'm a senior fellow at the Observer Research Foundation America and its Technology and Cyber Policy program. Today, I'm delighted to be joined by leading experts and colleagues who have been at the forefront of recent semiconductor developments in their respective technology, business, and policy fields. It gives me great pleasure to welcome Tara Hairston, Senior Director, Technology, Innovation, and Mobility Policy at the Alliance for Automotive Innovation. Chantal Lakatos, Senior Director, Government Affairs at LAM Research. Dave Rauchwerk, Co-founder and CEO of Sandmath. And also Paul Triolo, Senior Vice President for China and Technology at the Albright Stonebridge Group. With this, I'd like to hand over to our panelists and their opening remarks and introductions. Tara, would you like to go first?
Sure, happy to, Andreas. Thank you. And thank you to Observer Research Foundation America for having all of us. Really looking forward to today's discussion. So my name is Tara Hairston. I serve as the Senior Director for Technology, Innovation, and Mobility Policy at the Alliance for Automotive Innovation. So very long name, long title. We go by Auto Innovators for short. And I'm going to just briefly kind of describe who Auto Innovators is. So Auto Innovators is a trade association. We represent the auto manufacturers that produce nearly 98% of the cars and light-duty trucks sold in the United States, as well as original equipment suppliers, technology companies, and other value chain partners in the automotive ecosystem. You may not know this, but the automotive industry is the largest manufacturing sector in the US. We represent nearly 10 million jobs, and we also represent nearly 5.5% of the nation's GDP. Now, with regards to the US leadership when it comes to semiconductors, I think we would diplomatically say it's improving, and we're very happy to see that improvement. But we know that the industry has had a transformation in the last 30 to 40 years. In the 1990s, the US was responsible for nearly 40% of global semiconductor production, but now it's just around 12%. And we think it's really important that we learn the lessons of the past few years. We've all seen how a global pandemic, natural disasters, and other supply chain disruptions can really impact industries that are reliant on semiconductors around the world. So we think that it's important for the US at this stage, and as Andreas mentioned in his opening remarks, take a very holistic approach to evaluating these issues. And we do think that the CHIPS Plus Science Act is a really big step in the right direction. But we really look forward to the expertise of those in industry, those in academia, and in other sectors working together to make sure that the US not only tries to solve for the problems of today, but for the problems in the future as well. Thanks, Andreas.
Thank you, Tara, for this overview and kind of pointing out how important this your industry is in this overall conversation. Paul, would you like to go next, please?
Sure, and thanks, Andreas. Great to be here. I've been talking about these issues, it seems like forever. I'm currently a senior vice president for China, and I also head up our global technology policy practice at Albright Stonebridge, which is a DC risk consultancy. We have a lot of clients that are in the sector or associated sectors, and so we're talking semiconductors and ICT technology sort of on a daily basis, and particularly regulatory and other issues. When it comes to U.S. tech and semiconductor leadership, I think it's a complicated issue because, semiconductors means many different things depending on what part of the industry you're talking about. I just wrote a long memo for clients to help them understand the CHIPS Act, for example, and the implementation of the CHIPS Act, which represents arguably a major industrial policy step forward for the U.S., putting the U.S. on par with other developed economies in terms of providing these subsidies for advanced manufacturing, for example. So that's a good thing. It comes at a time, of course, when the CapEx expenditures for advanced manufacturing facilities are really high. So the U.S. has decided to jump back into that manufacturing game at a really tricky time in the industry, and we'll talk about some of those challenges that the U.S. will face in that arena. And of course, there's, as I noted, many complex pieces of the supply chain, and manufacturing is sort of where it all comes together to some degree, along with the packaging piece. And so I think the challenge for U.S. policy here is going to be to address all parts of that semiconductor supply chain piece, and how much should be onshored and how much can be, can remain part of what is a very, very globalized and geographically dispersed industry. So I think that's important. And then, as we'll talk about the export control piece, I've spent most of the morning reading through arcane Commerce Department documents with numbers like 744.6, trying to understand the full scope of the recent controls, which are profound. I would argue, and I think we need to get into some depth on how we talk about those. But really glad to be here. It sounds like we have a great panel. I haven't met the panelists before, but I'm extremely excited to engage in this conversation. And thanks for inviting me.
Thank you so much, Paul. And obviously, we're really also curious about your assessment, what some of those implications are. And those are just really difficult issues, right? There are so many moving parts, and what those effects are. I think that's will keep us, very busy over the next years, and I'm pretty sure about that. Chantal, turning to you, your industry, at the center of some of those conversations. Please take it away from here.
Thanks, Andreas. Well, I'm Chantal. I am a senior director in global government affairs at Lam Research, who is one of the world's largest semiconductor equipment companies, and we're headquartered in Fremont, California. And just, to level set, semiconductor equipment manufacturers, so we make the tools that make the chips. So our customers are the chip makers like Intel and Samsung and TSMC. So as Tara and you mentioned in the beginning of the session, smartphones, tablets, wearables, cars, automobiles, it's really hard to go more than a few hours without using a semiconductor-enabled device. The semiconductor industry touches nearly every person on the planet. Chip makers, who are our customers, they continue to advance that technology that powers all of it. And sort of my company, Lam's equipment and services, allow chip makers to build sort of smaller and better performing devices. That's sort of the overview of where we are in the many different segments of the semiconductor ecosystem. I'd like to thank you for including me on the panel, whose members I can tell all recognize both the challenges and a lot of the amazing opportunities facing the semiconductor industry today. While there are indeed challenges, I do think that semiconductor technology innovation remains strong. I mean, certainly in the equipment space in the United States, we do have a strategic leadership position. Now, there's no denying any leadership position is perishable, and so the policies that affect us, as well as our business decisions, we need to calculate quite closely. And there's no understatement as well that you could make that's saying that we're living in a very dynamic time when it comes to semiconductor policy. As Paul mentioned, the U.S. New regulations, which I'm not going to go into because it's still really being disseminated, but in addition to the CHIPS Act. So it's sort of this promote via CHIPS Act, which I think is really an unprecedented move for the U.S. government and Congress to pass. I think it will strengthen U.S. competitiveness, and it will shore up the ecosystem and foster research and development and growth, and that's wonderful. But there's also the protect piece, which is sort of looking at critical enabling technologies that any government wants to protect. That is not unusual. The U.S. has done it. There are multilateral export control regimes of which many countries are members of. So none of this is new. And I think that we can all learn to operate in whatever restricted as well as incentivized environment that we work in globally. So I'm going to leave it at that. And I look forward to the discussion.
Thank you, Chantal. And I really like how you kind of like broke this out, this protect versus the promote part. And I think those are both very important pillars that we need to talk about. And I think it's also a helpful framework to think about where those policy might go and who's buying into those policies and what some of those implications are. Dave, turning to you, I mean, you kind of are representing a very interesting group here. I think something that we not talk as much around on this policy conversations, kind of like, the startup ecosystem in the semiconductor industry that is actually very important to actually drive innovation. And you've done some really fascinating work, in a previous life, if you want. And I'd love to talk to you about this more, including your experience with getting chips from China.
Hi, so happy to be here. It's great to be, in a way, sort of the odd one out, insofar as I'm talking mostly about the role of startups as it relates to American semiconductor competitiveness. Now, I am currently the co-founder and CEO of Sandmath. We are working on a mass market game console. Previously, between 2014 and 2018, I was the CEO and co-founder of a company called NextThingCo. NextThingCo made the world's first $9 computer. It was sold in 120 countries and had a developer community of over 100,000 developers working on a larger open source project. And for us, the ability to collaborate across borders was foundational to how we were able to do what we did. Building effectively the software stack that goes on top of a modern SoC is something that has to date been the effort of thousands of developers in hundreds of countries as part of the Linux kernel project. So we sit here now, having been able to effectively stand on the shoulders of giants, and knowing how to build complex things with distributed teams in an open and completely cross-border world. As a small company, we sit here now, and the superpower we had maybe 6 months or a year ago or 2 years ago, where we could build teams from anywhere, is now coming into question. So, for us, it's also, we look at our peers who also are starting companies in the United States and elsewhere, and we say, well, there's a lot of large players, and we talk a lot about the large players, but if we don't invest in smaller companies now, who are the large players going to be in 20 or 30 years? Especially in the semiconductor business, we also have the problem of there aren't enough people doing this, and it's a sort of chicken and egg problem where we have very large companies being very successful and smaller companies struggling to find access to capital to get things off the ground so that in the future we can maintain our lead.
Thank you, Dave, for the introduction. And I think this is a very important point. I think to some degree, right, policymakers recognize the issue of workforce development is important. At the same time, you and I had interesting discussions around how, particularly, being both based on the West Coast, how Silicon Valley is much more used of a venture capital system that knows and understands software and platforms, but maybe doesn't have as much experience, nor the deep pockets, nor the time to wait to actually realize semiconductor investments, which run on somewhat different timelines. I'd love to talk more about this. I think this is a great start for this panel. Tara, I know we had I think in everyone's mind at the moment are those key policy pieces that we try to figure out and understand what some of those implications are. But before I think we go there, I want to maybe take one step back and talk to you and get your insights around, where does this actually supply shortage came from?
Sure. Thanks for the question, Andreas. So I think there's a couple of places where I want to try to respond to this, but I think one of the first things I want to mention is the fact that we keep saying semiconductors, and I'm probably going to say semiconductors and chips interchangeably, but I think it's really important to mention up top that not all semiconductors are the same, because the chips that may go into an automotive application are probably very different in the wearables or smart devices and other things that we use on a daily basis that use semiconductors. And I mention that specifically because that also kind of contribute to the supply chain challenges that the automotive sector was experiencing. So first of all, the automotive sector, to your point, Andreas, is like one of the fastest growing sectors using semiconductor chips. And they're using a wide variety of automotive applications, from vehicle control, safety, emissions, driver information, and other critical functions. But as I mentioned, they are different than other chips, particularly those used in consumer electronics. Automotive tends to rely on a wide variety of chips, but mostly what we're kind of associated with as an industry are mature nodes, sometimes referred to as legacy nodes, or sometimes lagging edge nodes. And Why that's important is because, the chips in the automotive industry must meet very high robustness and reliability standards because they have to withstand fairly significant and challenging internal and external environments for the useful life of a vehicle. So if you think about it, today, I think the average age of a vehicle on US roads is 12 years. I probably shouldn't admit this working in the industry, but my vehicle's about to turn 15 years old. So if you think about that in terms of not only the age of vehicles, but the fact that you need those parts and components to be able to repair vehicles for those longer periods of time that they are on the road, you need these chips that may not be the ones that may go into your cell phone, that smartphone, I should say, that some people may be replacing every year or so, for those people that like to do those sorts of things. And what are some of those conditions that require this really significant amount of robustness and resiliency? Well, we're talking about temperature ranges of around 4 degrees Celsius to almost 150 degrees Celsius, needing to have a life of at least 15 years, and for companies to have at least a 30-year supply worth of these chips. So these are very different kind of conditions than what you may see in the consumer electronics market. And so you mentioned kind of some of the production shortages, supply chain challenges, and other areas that were facing the U.S. industry, automotive industry. And so, we saw, for example, at the beginning of COVID, there was an unprecedented 8-week shutdown of vehicle production across North America. Now, there were similar closures globally, but that had never happened in the 100+ year history of the U.S. automotive industry. You had never seen over 2 months worth of vehicle production shutdown. You also obviously saw disruptions to manufacturing and packaging operations for semiconductors around the world. You saw, obviously, as well as we were all kind of stuck in our homes, this rapid increase in demand for consumer electronics. And then I would also say this resurgence in demand for personal transportation. People, as they maybe were willing to venture out, weren't comfortable getting on public transit. So they wanted to get their vehicles, or they wanted to be able to replace their vehicle. And so that demand definitely outstripped the supply.
Thank you, Tara, so much. I think this is also really fascinating because it kind of shows how other areas could be affected by those recent policies, right? And I don't know how much analysis has gone into understanding some of all those effects, not only along the automotive supply chain, but with other agendas such as energy transition and so forth, how that might be affected. So I think that might be a completely separate panel, but this is fascinating to hear. Paul, turning to you for some guidance on some of the geopolitical issues, right? So I think the big, it's not the elephant in the room, but the big question in the room here is China, U.S. China relations, which I think is kind of the driver behind the current policy conversations that we are having. How do you see those dynamics being played out? And also, when you compare, you have unique insights into U.S. versus China semiconductor leadership and maturity. How would you define that?
Great question, Andreas. And I think just quickly, the semiconductor piece of this is part of a broader U.S. China tech rivalry, if you will. It's much broader than semis. Of course, during the trade talks in the Trump era, we were talking about Made in China 2025 and subsidies, which come into play in the semiconductor arena, and things like forced tech transfer. The national security concerns, though, that have kind of gotten a little more heated over the last 2 years, and which were raised by National Security Advisor Jake Sullivan in his comments on the U.S. national security strategy that was also released this week, and on the recent export controls. They highlight things like China's military modernization, specifically things like military civil fusion, and there the real issue specifically are things like artificial intelligence and high performance computing, which, by the way, are underlain by foundational technologies like semiconductors. So I think that's sort of the bigger picture you have to look at here. When you look at the differences between the industries, let's be clear. China's semiconductor industry is not really competitive with the U.S., right? And virtually any subsector, none. I wrote a paper last year, a longer paper, in a detailed look at the Chinese semiconductor industry and all the different subsectors. And then I did a column recently on the CHIPS Act, where a lot of the language around the CHIPS Act was competition with China, but that's not really what the CHIPS Act is about. It's more about jumpstarting U.S. manufacturing, which everybody agrees is a good thing. And it's about reducing geographic dependence on TSMC and Taiwan for advanced advanced node manufacturing. So that's really what it's about. It's competing with China in a sort of a loose way, but not really in the sense that, China is developing companies that can compete with the likes of Lam or any other U.S. company. So when it comes to, China, it's really serving primarily as a market for U.S. semiconductor companies, both fabless design firms like Apple and Qualcomm and NVIDIA, and tool makers like Lam, like Applied Materials, like Tencor, and of course, EDA tool designers and companies like Synopsys and Cadence. And there really are no Chinese competitors to those, at least on a global scale, maybe in a small scale within China, but certainly not globally. So I think that's an important point to make. So most of these subsectors, you could argue, Chinese companies are 5 to 10 years behind their U.S., Japanese, or European counterparts. When you talk about the industry too, you have to bring in Taiwan. And that gets into some of the geopolitics. So Taiwan Foundry, TSMC, for example, is in a sense an integral part of China's semiconductor industry. Because in the areas of design, for example, where Chinese companies are doing pretty well, they're probably most capable in terms of competing with U.S. firms, those chips that they design are all manufactured in Taiwan, at least all the cutting edge chips. So the degree to which, for example, the U.S. cuts off TSMC from Chinese firms is a serious issue. I've written quite a bit about that, sort of an unknown red line for Beijing. And then we've had, of course, Huawei and the Chinese CPU maker Phytium cut off here. And with these new restrictions, which we're going to get to talking about, any firm designing a GPU, a Chinese firm designing a GPU, for example, with a high performance, is certainly probably not going to be able to manufacture those in Taiwan. So necessarily the competition is there, but you have to step back a couple degrees, look at Taiwan, and then look at these broader national security issues, which the U.S. is becoming increasingly concerned about regarding China's military modernization. And the language you see around even the CHIPS Act, right, is Secretary Raimondo talking about this as a national security issue. She's referring specifically to the ability of U.S. companies onshore being able to manufacture advanced semiconductors for the U.S. military. So the national security issues are really boiling down here in many cases to sort of, whose military is going to deploy the best semiconductors in a whole range of applications.
Thank you so much. That's really helpful. Chantal, turning to you, I think one of the things that many people still trying to figure out and understand is so how are those chips actually made? And with this, I don't mean necessarily on a technical level, but kind of can you kind of outline a little bit more of the global supply chain, and to the degree some of the those recent, particularly the CHIPS Act, has helped to address maybe some of the challenges that the industry is facing.
Well, thank God you didn't ask me to tell you how a chip is made. So, because that would be challenging. So, from my perspective, when I look at sort of the global supply chain and globalization of our industry, as an equipment manufacturer, we are wherever our customers are. Our customers make chips globally, all over the world. We have to be there not only to service and maintain, to engineer, but to solve problems with our customers. Customers have evolving requirements, as Tara mentioned, about different aspects of chips for automobiles. They all have different requirements. They have different problem sets, and we need to be there to help them solve those problems, which goes into our learning, which helps us innovate in the long term. So no matter what, we are going to be everywhere globally because that's how it works. Now, for, sort of understanding the equipment space, there are, roughly a handful of the larger equipment manufacturers in the world, and we all occupy different parts of the value chain that will, with all those parts connected, create a chip in the end. I will say, though, because it is such a highly concentrated and yet connected global ecosystem, no one fab, no one company, no one country can handle every aspect of making complex chips. It is so multi-segmented, and the supply chain is so vast and multi-tiered. I don't think that the criticality of semiconductors is definitely increasing, and everybody talks about the pandemic and what that meant. for the supply chain, and really, exposing certain amount of vulnerabilities within the supply chain, not only for everything that chips go into, but for chips themselves and making them, because making chips requires chips, which is an odd thing to think about, but true. So I think that, leadership in the cutting edge development is really dependent on global manufacturing, where that's happening, and the R&D footprint, because as Paul mentioned, R&D and how we do that and how we collaborate with partnerships with customers around the world really does affect the ability to innovate and maintain leadership positions globally. I think that, when you think about the supply chain, and I know that, this is sort of a trite saying, but everybody working together, the industry is so multifaceted and multi-segmented. Working together, collaborating, innovating, it really does ensure that we'll maintain leadership positions and will build strength and resilience throughout the supply chain for future challenges. Now, the CHIPS Act absolutely comes into that. And, by the nature of the business being global in itself, that ecosystem being global, governments are going to look at that, promote and protect. They're going to incentivize where they see gaps. I mean, the CHIPS Act, Paul very, articulated very well the rationale behind the CHIPS Act, and to a degree for manufacturing and research and development, which, I may talk about a little bit later. I do think, though, that they also look at those critical technologies that are either, as Paul said, national security driven, to try and protect that technology, to share, perhaps with partners. There is no way to have every part of the ecosystem housed within the four corners of any one piece of the puzzle. It has to be spread out and diversified, because that is how the supply chain works. And as you see countries identify sort of gaps in their own supply chains or advantages they may have in terms of knowledge, talent, labor, you'll see them working towards incentivizing those in any particular country or economy. And so this adaptation, I think, will take place certainly more so probably since the pandemic, where everybody is looking at where's the fragility, where can we build, where can we invest to build resiliency, how can we partner with global partners, customers, whomever, governments, to shore up where we see those vulnerabilities. So I think that will continue to happen, and I think that, albeit, you talked about in the beginning and Paul talked about in the beginning, the economic sort of flow, I still think that will continue.
Thank you, Chantal. I really appreciate that. Dave, I'm curious, we kind of touched on that a little bit before about, the role of semiconductor entrepreneurship and how that currently looks like, and maybe you can fill us a little bit more in about why this is so important for innovation in the sector overall.
Yeah, I mean, in our past conversations, we've talked a lot about this, and I've always sort of thought about innovation in the semiconductor space, much like logging. It's that if we can harvest from the forest that we have now, but if we don't plant new ones, we're going to have to wait 20 or 30 years to find out that we don't have anybody that knows how to make microchips in the United States. We don't have anyone that knows how to develop EDA tools. We don't have people to work in the fabs, people to maintain the equipment. It's that we're constantly, as a small company, subject to the challenges of the current market, but also in some way the basis of the future structural security of that market. I mean, the companies that were responsible principally for profiting from the commercialization of the CMOS process are still in business. And, the question is going to be, are we even going to be using the CMOS process in 30 years, right? And those kinds of questions, it's very hard for a company that is engaged in and when we really talk too much about this because we're all in this business in some way, but this is this is the most complicated business on earth. It involves every single scientist and engineer working at the frontier in every country that has those scientists, and so if you're focused on trying to win that race where we're trying to get faster, smaller, cheaper, better yields, more features, there's not really that time to take your heads up and focus on, or even have a team focused on where are these potential disruptive opportunities in the next 10 years? What is going to come after the CMOS process? And it's not, I am honestly, it's hard for me to criticize the semiconductor industry as a whole for not doing enough research, because it is the most research intensive group in the world and spends more on research than anyone else. But as the sort of tip of the spear, as it were, we as a community need to be investing in the next generation of people that are doing this. And if you look at what's going on, and one of the challenges, in the United States, for better or worse, venture capital is the mechanism by which we take innovation and we get it into the hands of people, companies, and governments. It is the mechanism that we've got. And it was a mechanism of financing and innovation that was principally a growth out of Silicon Valley, where microchips were invented. And you talk about the founder of Sequoia, Don Valentine, he was a Raytheon sales engineer, and then he joined National, and then he was at Fairchild, right? And he'd say, in the semiconductor business, we get to see the future because we're always working on what's going to come out in 5 years. And we're sitting here right now as the industry that invests the most in R&D, and we're entering financial headwinds. We can all see the future. We know it's cyclical, but if we don't step up and start thinking about, okay, well, how do we get more people to do this? Because the really sort of complicated point I'm trying to articulate is that workforce development and supporting startups and investing in the next generation of startups are directly connected. If the best engineers are not economically incentivized to focus on electrical engineering and semiconductor manufacturing and working on the tools to produce microchips and the software to design them, they're going to continue to go into industries that are not related to chips. The current crop of venture-funded companies, some of them are fantastic, some of them are highly problematic. We don't need to go through any of that. They are effectively free riders on infrastructure that was built and created and supported by the government in the 70s, 80s, and 90s. You don't get Uber without Semitech. Is sort of the point I'm trying to make. And those two things are directly connected. And now we're in this spot where we need to be developing the next generation of people doing this, supporting the group of people doing it now, and making sure that we're coming up with the ideas that are going to drive innovation on it, frankly, in the next 30 years.
Thank you, Dave. This was actually super fascinating because I think it really drove home how those multiple parts kind of fit together, and that at least I have not seen that part of the discussion besides the workforce development, broadly speaking, right? That would be actually really important for this innovation piece, not only at big companies, but kind of this, the smaller field, so to speak, that invests not in the next generation of chips, but in capabilities 1 or 2 decades further down the line. So I think that's a very important thought, and I think we need to think more about this as well. I feel like we're just getting started here, but looking at the clock, it looks like we're coming slowly to an end. And so what I would like to do is kind of do a kind of 2 parts here, which is kind of everyone has a final statement, concluding remarks along the lines of where do you see U.S. semiconductor industry or global industry, semiconductor industry in 5± years. If you like to, feel free to tie in the Chips Plus Science Act or the export controls. But also I think some of the themes that came out here, I'm actually curious, for example, Paul, right? From a geopolitical perspective, do you have any particular expectations with regards to how China might respond to these new rules, but also questions around decoupling, industrial policy might be something maybe someone else would like to touch upon. Paul, since I just mentioned your name, do you want to go first with short concluding remarks?
Sure, Andreas, that would be good. I wish we had a little more time to get into the CHIPS Act, because I think that's an important piece of this equation as we look forward about where the industry is going to be in 5 years. You have both the CHIPS Act, of course, and the EU CHIPS Act. And both of those are looking at new government incentives to sort of restructure and particularly geographically the industry. And so the success of those efforts, I think, is going to be really the big determinant about what the industry looks like in 5 years. Now, on the U.S. side, of course, the CHIPS Act money will go initially to companies like TSMC and Samsung and Intel and Micron. And the U.S. is attempting through that process to develop these clusters, because the industry really is built around clusters. That's why Taiwan has been so successful, et cetera. Europe is trying to build clusters in Magdeburg and other places in Germany. So in the next 5 years, we're going to see whether the industry sort of commercially, these things make sense, right? Because it's tricky. In the U.S., you already have a good cluster in Arizona. You're going to have one in Texas, likely with Samsung. You'll have one in Ohio with Intel, and an R&D cluster probably in New York, thanks to Chuck Schumer, who's been so successful at getting the CHIPS Act through. So all of this will be important to look at. And then, as I think it was Chantal noted, but this is a global industry, right? And so the fundamental nature of the division of labor will still not be changed in a huge way. Even if the CHIPS Act is wildly successful, Taiwan and TSMC will still produce probably 70% of the world's most advanced semiconductors, right? The US will chip away at that, and maybe there'll be a couple of fabs in Europe. And then you'll have a very much more complicated next generation of packaging, for example, where the US and Japan will likely play prominent roles here. So there will be a lot of restructuring. One of the wild cards, I would say, is Taiwan. If there's a US-China conflict over Taiwan in the next 5 years, then all bets are off. TSMC can't survive for a few hours without all the global inputs coming in, all the process gases and the tools and the technicians coming in, right? So there's a lot of geopolitical uncertainty around these conflict areas, like both Taiwan and China, and of course North Korea and South Korea. All the huge percentage of the world's DRAM production is miles from the demilitarized zones in South Korea. So lots of geopolitical uncertainties around the issue. And then finally, I would just note, the export control piece here that we're seeing here is really important, and how that plays out and impacts the industry. We don't know yet, but if the initial indication is that it's going to be a lot more messy than the Commerce Department probably intended, with lots of unintended consequences, lots of collateral damage here. So my recommendations would be to governments, not just the US, but general governments, is to intervene very carefully in global semiconductor supply chains, really understand how they work, because the potential for these unintended consequences is very high because of the complicated nature of the industry that Chantal so ably described to us here. I think it's really important to understand that.
Thank you so much, Paul. I think since Chantal, your name was mentioned quite a few times, and I think you might be very sympathetic towards the recommendations that Paul put out there. So you should be next.
Well, thank you. And yeah, Paul, that was pretty extensive. I'm going to stick with my optimistic innovation because that's what we do, right? Speed to innovation is really one of the cornerstones, not only of my company, but about the industry. When Dave talks about this whole, people are innovating now, we'll see that in 5 years. So I think, when you think about the CHIPS Act, one of the things that I think is one of the most important parts of it really is the NSTC, which is the National Semiconductor Technology Center that is part of it. That will sort of underpin how industry and academia and government, sort of advance the US's technology roadmap. So it will create all kinds of research and development, and it'll provide sort of this novel pathway to a more secure sort of domestic supply chain. I think it will also help identify gaps, and it will bring those people together. It will also, which I think is very important when you look at entrepreneurship and innovation, it'll sort of increase domestic fab capacity so that we can create opportunities for innovators to, from various disciplines, really to collaborate on new concepts, from new technologies to innovation to actually a production line. And those are going to be critical. That's going to be all critical for the future in the US these innovations. I think that it's a novel approach, and I look forward to, however we can all participate in it. Certainly my company works with academia and we work with all of our global partners, but I think this is sort of a novel approach, one of which I haven't, the government has deployed, years ago in sort of military applications and so forth, but I think that this is really going to lead to some cutting edge innovation in this country. So in our industry, which is a good thing. And that would be sort of, if I had a recommendation, to let that happen and foster that and use that mechanism to create avenues for entrepreneurs, for innovators, and for doing what, we do best. And creating the speed to do it. Because it is also, innovation is, it is about speed. I'm sure Dave would agree with me.
Well, I think that's a very good segue. Thanks so much, Chantal. Dave.
Yeah, I mean, Chantal, you're hitting all the points. I'm a huge fan of the NSTC, and effectively, yeah, it is. We need to create financial incentives for private investors to team up with the government. It's not, I mean, the incentive enough should be you're investing in the future and you're going to make enormous amount of money because the companies that are small now that create new technologies, if it's even photonics related, if it's quantum computing related, whatever it may be, if it's whatever comes after the CMOS process, anyone who is involved in the creation of those companies is going to do very well. But unfortunately, the way we have created this market, zero interest rate policies have forced people to say, well, I mean, there was unlimited free money. We're going to pick the thing that has the highest margin. Turns out that's software, right? It's pure software as a service companies have the highest margin, which has over the last 10 years, in a way, really harmed the ecosystem for people that are interested in working in the semiconductor space, right? And it's been, I think, a boon for the larger companies, but now it's created, I think, in a way, a weird market failure condition and some structural instabilities. We're entering a down cycle in the semiconductor business, and at the exact same time, we're also committing to adding enormous, unprecedented fab capacity. So, I am actually very bullish and very positive about the idea that we're going to wake up in about 2 years' time, and there's going to be enough fab capacity for every company that comes out of a state research institution that says, hey, instead of going to a postdoc, we can get fab space in Ohio, and we can, it's not just a shuttle run. They guaranteed us a certain number of wafer starts, and we can get our chip to market. And that has not been a situation that has existed in the United States for a very, very long time. There are a lot of headwinds coming our way, and as a business person, uncertainty is my enemy. But I know that as difficult as it is right now, if we're able to get everyone, even within the United States and with our larger group of international partners, to work together, we're going to get there. I'm just want to make sure that we put in place the incentives, and whatever we have the ITC, we have a tax credit for fab construction, but we don't have a tax credit for investing in new semiconductor companies, right? And we do need to put our fingers on the scale in that way to say it's guaranteed a great idea to start more microchip companies, because that's if anything is going to solve the problems that we're going to encounter in the next 5 and 10 years in the technology industry, it's going to be new fundamental technology that comes out of the semiconductor space.
I like that. I think I've heard the phrase somewhere about the dividends of the chip war, but in someone that's slightly different, the previous iteration of this. And so I think you pointing at that, this might be the next wave where we, once we go through this this not so pleasant phase, that we might have significant capacity to do very exciting things in the next 5 years and beyond. So that sounds like a promising endpoint here. Tara, turning to you, you started with the consumer perspectives in terms of like automotive, right? Where do you see this going for your particular industry in the next 5 years, and what are the consequences thereof?
Well, it's pretty intimidating to have to kind of close out this wonderful discussion, but I would say that I share the optimism of my co-panelists, particularly from our industry's perspective, because of the fact that the automotive industry is really in a transformative space and a transformative time. I mean, we've talked about electrification, particularly earlier, because of some of the joint ventures that are being mentioned in the battery electric and electric charging space, but there's also some other significant trends that are being pursued, for example, with regards to automation, as well as increased connectivity in vehicles. And those trends are being supported by semiconductors as well. So I think as the underlying semiconductor related policies that Chantal and Paul and Dave have all discussed today come together in a way that is like very holistic and hopefully don't disrupt the supply chain for the sake of disruption. And really kind of not only support the semiconductor industry itself, but also the end users of that industry's outputs. I think that industries like the automotive industry really have an opportunity to achieve significant changes that are not only meeting consumer demand, but are also meeting broader policy goals. Like electrification is not just because everybody wants to have that cool car. It's also because we're looking at things related to climate change and things like that. And connectivity and automation also relates to vehicle safety and reducing road fatalities and protecting vulnerable road users. So there are these broader policy goals that are being pursued through industry innovation. And so it's the end users, it's the industry that makes semiconductors, it's the equipment manufacturers like Chantal and her company. And I think those are all really important spaces. So from my perspective, there's a couple of recommendations. One that is probably solely within my personal capacity, because I've been really impressed by today's conversation. And I think this is maybe just kind of speaking more to what Dave and Chantal have raised in the context of small and medium-sized enterprises and startups have not really been considered part of the conversation. And from my perspective, just in terms of other things that I'm hearing or other areas that I'm working on, that really needs to be kind of considered part of the supply chain resiliency imperative that the government's pursuing, and it's not. And we have to figure out a way to get the Commerce Department and the White House and its various little sub-agencies to really think about that as investing in the supply chain and not just as kind of the economic incentives that came out of the CHIPS Plus Science Act. So that's just kind of my little plug of figuring out how do we kind of contextualize these issues differently to get the right attention. Now, putting back on my trade association hat, the other recommendation that I think is really important, and this is going to go fairly left of field, so my apologies in advance, but I think another area that really needs to be focused on in the context of semiconductor industry policy is intellectual property. And you guys are probably all thinking, what in the world is she talking about? Or A, why is she bringing this up? But there's another aspect that is constantly kind of impacting users of semiconductors, semiconductor manufacturing companies, et cetera, in the sense that a lot of the technologies that are going into products, for example, like cars, where you're talking about 4G LTE, 5G, soon to be 6G, or whatever else that may be coming down the road, are these standardized technologies that are heavily dependent on semiconductors. And those standardized technologies often have patents associated with them. And there's often this conversation around, are those patents being licensed on fair, reasonable, and non-discriminatory terms? Is there kind of an equal ecosystem for the people that hold those patents and the people that have to license them? So I just mentioned this because this is another supply chain resiliency issue, is the IP policies that surround these standardized technologies that are based heavily on semiconductors, is that ecosystem fair to all parties? Because there are some worrying examples where people are alleging infringement of patents that are either put into semiconductors or into components and parts that use semiconductors. And, that has the potential to keep parts and components out of the United States through exclusion orders issued by the U.S. International Trade Commission. It has the possibility of extracting a lot of value out of innovative companies because they're having to settle these ridiculous litigation settlements. So there's all these other sorts of aspects of intellectual property that kind of cross-intersect with semiconductor policy that, again, aren't necessarily getting the attention, but they are definitely having an impact. And I think that's another area where there needs to be some focus to make sure that the IP aspects that kind of are part and parcel of this industry are really working to, again, support the industry and supporting itself as well as the companies that use the products that it manufactures.
Thank you, Tara, for those fascinating final remarks and opening up a space for at least one other, even not more, roundtables and conversations around these issues. I mean, and we haven't even touched upon things like, what happens once the U.S. subsidies run out, and all those other topics that need to be addressed to really think about how we go to year 5 and year 10 and so forth. So Dave, Tara, Paul, Chantal, thank you so much for this fascinating conversation, wide-ranging as it is, and I look forward to our next talk on this as well. Thank you for being here with us for the CyFy panel, and have a wonderful day.